Well, again, nice to see you, all you guitar and amplifier nerds. Well, I know I don't see you, you don't see me, but what we can see together is this nice Music Man amplifier. It's on my bench in for service and repair. So if you're interested in a very unique and unusual amplifier, then stick around. Well, Music Man amps were quite popular in the late 70s and 80s. Guitar heroes like Eric Clapton used this amp exclusively. You can see him here in front of a wall of amplifiers made by Music Man. But also Albert Lee was playing Music Man amps. And yes, Marc Knopfler, the Dire Straits, also played Music Man amps. Two more guitar heroes worth mentioning are Johnny Winter and the fabulous Muddy Waters himself. And a guy you might have heard of had at least an influence when these units were engineered. Yes, it was Leo Fender. So no doubt these amps cannot be bad. The design is pretty revolutionary because these amps were, I assume, the first hybrid amps ever. A solid-state preamp combined with a tube output stage. But before we start troubleshooting, let's take a look at our example. This little plate on the front grille tells us we have a 12-inch speaker. The RP means reverb and phaser, and an output of 65 watts. The design of the cabinet is obviously inspired by Fender, though the front is more slanted to give the player more monitoring while he's playing that thing. We got two inputs, a bright and a deep switch, gain control, treble, mids and bass control, a reverb and a phaser effect. The phaser can be adjusted. And last but not least, we have another volume knob. It's more or less a master volume. We can see two line in and out jacks, the power switch, and a three-way standby switch that allows you to dial in high or low power. And we will take a closer look at that later. Not a lot of stuff going on the back panel. A fuse. Lots of information on this plate and the magic words made in California. We have an impedance selector switch, a speaker output jack, and that's it. Alright, to identify this amp we find a lot of stamped in numbers on this plate. A serial number, the input voltage that requires 220 volts. Yes, it's an export model. We have the output wattage and the model and the chassis number. No more questions, right? The speaker confuses me. It's an Celestion speaker made in England. An English speaker and a Californian amp. That might be original, but I don't know. Maybe somebody of you amp nerds can help me out. Okay, the chassis is out, and we have a pair of tube amp Dr. EL34 with a cog label on the tube base. They are definitely not original. In the back we can see a doghouse covering the HT caps. Looks pretty Fender-like too, right? The transformer code will help us to nail down the age of this unit. Let's take a look. Well, this amp was made in the 14th week in 1979. And here's the inside in all its glory. Looks very clean, tidied up, high quality components and nice craftsmanship. Really, I like it. And by the way, Pat signed the board in July 1979. So now it's time to troubleshoot this beast. Let's open the hood and take a look under the doghouse. It's not really good to see in this picture, but this cap has a bubble right here. And the other one, really crusty. Sure, a replacement is needful. And here on the board there is another capacitor that is squeezing out his inside. You can see this crap here coming out of the cap. So I'm going to swap these 4 caps out as well. But let me show you the main problem this jam has. These dropouts and crackling noise is not caused by a dirty or defective pot. Let me show you the reason for this strange behavior. Here you can see what's really wrong. We actually have a DC leakage. We have 1.8 volts of DC in the signal path. And that can cause several issues. In this case, not only dropouts and crackle noise. In this case, the amp produces funny distortion when played, and it sounds very unpleasant. But that will be my task for later. I will start with the replacement of the decrepit capacitors. Yeah, well, it's time to say goodbye to these old Mallories. Secure the new ones with a drop of silicone. I know it's a wrong brand, you know, Engel, well, but you have to take what you get. These capacitors were the only ones with the right value and a reasonable price. So who cares what kind of label they have? Note that I marked the plus and minus side of the caps with these little tags. I do that because sometimes I stop working for some reasons and I get back to the amp days later, and with these little marks I don't have any questions and no doubts what to do. So now we put in 4 new caps on the board. No big deal either, because as I mentioned before, it's really high quality. It's easy to flip the board around. It's easy to get the parts out and in. Really, I like the quality of this amplifier. It's really good and high quality. So you can see when I solder in the new capacitors, I bend the leads around a little bit to give them a better physical connection. Snip the leads, and we are done. But now let's get back to our main problem, the dropout/noise problem. Well, after I checked the caps for leakage, I came to the conclusion, or should I say I had a feeling or instinct, that the problem might emerge in the preamp section. And rather than spend time tracking down which IC is faulty, I ordered a bunch of them. They are dirt cheap, 65 cents each, and they are all the same type and value all over the amp. And well done, music man, they are sitting in a socket, so it's no big deal to change them out. So let's take a look if the leakage is gone and if the new op amps will solve the problem. Let's see. Okay, we got the same situation like before. I hooked up my voltmeter, fired up the amp, and hooray! I nailed it. No DC voltage at all. The leakage is gone. I have a good feeling. It's nice to be successful. But how about the dropouts and the unpleasant distortion? Let's see, or let's rather hear how the amp is acting now. Yeah, man, it works. No crackling noise, no dropouts, no nasty distortion. Yeah, I'm pretty satisfied with this result. But still, there is some more work to do because it's a full service, isn't it? So let's take a look at the output tubes and how they are doing. I hooked up my tube tester, plug the tube in, and oops, that's looking not perfect at all. This tube is a little bit weak. Let's check the other one. But it really makes me wonder, We have high quality tubes supplied by the tube amp doctor and selected for Cog amps, and they're in such a bad shape. How can that happen? I don't know. But maybe I have an answer. Well, maybe you remember the three-way switch. We have a standby position and we have a selection between high and low power. Well, here is the voltage in the low power position, and we have 514 volts in the low position. And now we take a look at the high position. And here we have 760 volts. Man, that's scary, isn't it? So let's ask my trusty old tube manual about the specifications for EL34s or 6CA7 powered tubes. And yeah, let's take a look at the plate voltage that is required. In a Class A amplifier, the plate voltage can go up to 800 volts. But that's in Class A amplifier, and in this case we have an AB, push-pull circuit. And the guys of RCA are telling us not to exceed 450 volts. Though this is very conservative, but 760 volts, man, that is so excessive. It puts so much strain on these poor tubes, and that might fatigue them over time. But whatsoever, this amp needs new power tubes, and the new power tubes need to be biased. Here's a picture of the bias supply. You see a trim pot, 2 diodes, and 2 3.9 ohm resistors. Underneath the board you can spot the transistors which are responsible for the phase splitting. The procedure of bias setting is totally different from any other tube amp I know, so I had to consult the service manual Music Man provides. Here it is. I'm going to choose the second option, using the voltage drop across the 3.9 ohm resistors. But let's take a look at the schematic first, and you will see how different and strange this bias circuit is. Here are the 2 transistors acting as a phase splitter. Here's the little trim pot, and finally the 2 3.9 ohm resistors. And note that the phase inverter transistors are tied to the cathode of the output tubes rather than the grid like in all tube circuits that I know. Strange, isn't it? Whatsoever, let's set the bias. So here I hooked up my voltmeter across the 3.9 ohm resistor, and I'm going to set the bias to 25 millivolts as required. So yeah, that's quite spot on. Yep. Okay, let's check the second voltage drop across the other resistor. Oh look, the second voltage drop is quite similar. Not bad, isn't it? But let's double check it. Okay, that's a hair too high. This little trim pot is very sensitive. Yeah, now we got it. All right, the other one is very close, so I call that done. Alright, and now I'm getting ready to torture you with my guitar playing, but before I start that and we listen to the legendary Music Man RP65, these three guys got a message for you. See you the next time. Take care.